And it's COMP305. It's week 2, lesson 2, part 3. This is kind of the day 2 of this cycle, this week. And what we're talking about today is some really important stuff. I've been talking over the last little while, or at least last week, and even yesterday, the day 1 piece of this one, about the execution order of event functions, or the Unity event lifecycle. And you know, some of you may not understand what that works like, but who's ever programmed in Android? Anybody? Right? If you're ever programmed in Android or an iOS or any kind of other system, when you're programming a device, right? You're using different kinds of code. You might think that in Android you're using Java, right? But actually, it's not really the Java that we learn here, right? You use the Java syntax, but what you're actually doing is consuming the API, right? So you're actually using the methods for the event lifecycle for the device. Same thing with iOS. You might be using Swift or Objective-C, but at the end of the day, you're not using pure programming concepts, object orientation necessarily, using built-in methods that are inherited that you have to override. That's what you have to do. Same here in Unity and other things like Unreal. And we'll talk about that very shortly. So what are we going to do? We're going to talk about this session. We're going to talk about Unity's event functions. We're also going to learn about Unity's game object class, which is like the main class that we want to be working with throughout the time that we're together here, right? And also about Unity's input class, which is the way we can affect game objects in our scenes. Okay, so we're going to do that together, right? All right, let's take a look. So again, there's a variety of different time frames, and if you want to talk about the life cycle, kind of goes like this. It starts off by updating the editor, then the first scene load. Finally, it goes into before the first frame updates. In between frames, it does a certain update order. There's rendering. It does the coroutines, and then finally it goes into the when the object is destroyed and when quitting the program, right? So these are all different times and different events that occur, or groupings of events that we're going to talk about. Okay, so let's take a look at it from a graphical perspective. And by the way, if you ever want to look at this online, and I think it's a great thing to do so, if I just look for execution order of events, of event functions in Unity, let's just look that up, right? Execution order events function, there it is, right? If I do that and I go here, you can actually follow along online as well. All I've done is break it down for you in PowerPoint presentations to kind of chunk it for you so you can find the information. So this is kind of the life cycle in a graphical format in one big image, right? But we're going to kind of chunk it down for you here. Okay, so let's take a look. So the first piece, if you can see this, I'm just turn down the lights a little bit, is the editor. And in the editor, there is a reset method. I'm just going to kind of zoom in here so you can see. So here's the reset method in the editor, right? And in the editor time frame, right? Then there's the initialization phase. This is another phase, right? And where you have a few different methods, the awake method, the on-enable method, and the start method. The awake method is something you may use in your time with us together. Also, the start method. On-enable, probably not as much, okay? It's something that you can call again and again, whereas the start method only fires once, ever. Whenever you first instantiate the object and it enters the scene, that's when it fires, that event. And we'll talk about these. So these are all built-in methods that you need to override if you want to use them. Now, they're all optional. They're not mandatory. So you can have a script that does nothing, right, if you want to. It's up to you. But these are the ones that actually make your scripts work, these methods, okay? Then we get into the physics phase. In the physics phase, we have a fixed update. We're going to talk about what the difference between fixed update and update is, okay? It's the same, almost the same name. But fixed update is the one that works with your physics, right? So if you want to change the location of something by pushing it with physics, adding a force, you use fixed update, okay? If you want to change the location from XYZ to XYZ, you use update, okay? It's a different thing. And remember, all of these things fire every frame, okay? So every frame. So the typical way it works is your game runs around 60 frames per second. So that means 60 times per second here in the physics phase, you know, there are events. We're listening for these kinds of physics-like events, right? You have something called a yield, right? And this yield method, yield wait for update, wait for fixed update, is another coroutine that you can kind of run on the way on the kind of just after the fixed update. Okay, and we'll talk about that a little bit later. Then you have a couple of you have the internal physics stuff going on where if an object moves in physics or is pushed, the physics engine itself updates the locations automatically across the entire world in the scene. So imagine you have the entire world in the scene. You set things in motion. It's going to kind of continue the motion according to gravity, mass, friction, all that kind of stuff that physics is that has built into the physics engine. And we're using the bullet physics engine here in Unity, right? Then we're going to actually listen for a couple of different kinds of events. One is the on-trigger events. On-trigger enter is probably the most common. And also then afterwards, it's going to be the on-collision. The on-collision enter would be the next most common one that we look at. So then we get into the input phase. And the input phase is where we listen for mouse events and keyboard events. And a good example of that is on-mouse enter or on-mouse leave and so on. Those on-mouse events happen in the input phase. We listen for that. Finally, we get into the game logic, which is where our main game loop lives, right? And we actually hit the main or update method. And this update method, again, we can use this for updating things every frame. Now, here's the challenge. If I use an update method and I'm updating every frame on a desktop, I'm going to have pretty good performance. I'm going to have pretty stable 60 frames per second. What about on a mobile device? Depending on the mobile device, I might get 59, 58. It could be 50. You never know, right? So is the update method always going to be the exact same? And the answer is no. Whereas the physics update is the fixed update is the exact same. I call it the physics update, fixed update in my head because that's what that's how I kind of relate it to. So the update method is actually variable because the frame rate is going to fluctuate according to the device that you're using, right? That's why it's a really good idea if you're doing physics to use a fixed update and not the update method, because otherwise it'll look chunky at times when it comes to the actual physics that are going on in the background, right? Finally, you have all these other little routines. This is all part of the yield. All these yield methods are part of the coroutine, right? Then we get into the internal animation update. So let's say if I want to do some kind of walk cycle, I have some kind of rigging that's attached to a character or something like that. That happens here in the game logic phase, right? That happens automatically when you set the animation rate. And it does all the in-betweening, all the tweening, if you will, from one frame to the next, right? Because we do frame-based animation here, right? And then finally, we have something called a late update. So we have fixed update, update, late update. Why would I do the late update? Well, sometimes what I want to do is do my update, change positions of things. And then in my late update, sometimes that's a great place to do things like update my score, all that other stuff after everything's moved and I have explosions happen and all that kind of stuff, right? Sometimes. Again, I'm just kind of framing it for you so you can see where what we're doing. Finally, we have this scene rendering phase. And I'm not going to go through all these methods, but all these methods are related to redrawing stuff inside your game world. Okay, so when I do a refresh, I actually physically redraw the objects according to my physics, according to my animations, according to what you've put in your game logic. I redraw everything, and I do that after the update phase. So after I do the game logic, I do all my scene rendering, right? Okay, let's go to the next one. And then I do a bunch of other stuff with the, for example, I do a gizmo rendering. So if I'm looking at the manipulator arm and I want to see that in real time when the game is playing because I want to manipulate something in real time, then that's when the gizmo rendering happens. The GUI rendering refers to all my text, any kind of UI, GUI, that means like any kind of buttons that I kind of implement in the scene. All that stuff happens after all the updates happen, right? So I kind of render the UI, and then finally I'm into the end of frame. So finally I finish all the whole frame, 60 frames per second. It's over. Now I go to the next frame. I'm ready to go to the next frame, right? There's also this on application pause method that I can access. So if I pause my application, because sometimes that happens if you leave the game. In a mobile device, it happens automatically. It goes to the background and the game a lot of times pauses. iOS restricts you from running things in the background as an example, unless you specifically get permission from the user, right? And sometimes Android pauses you as well. right? I'm just giving you a mobile example, right? Or you can physically pause the game by pressing a pause button or something like that that you implement in your game, right? You can also enable, disable all game objects in the game, and when the object is disabled, you can listen for that effect. And of course, that's why it links back up to the on enable. How often do we enable, disable objects? Well, you know, it can be used as a technique. If I want to, when I enable an object, it physically appears in my scene. When I disable it, it doesn't appear in my scene, although it's physically in my game, right? So it can update location, all that kind of stuff, but it just won't appear in the scene at all, right? And then there's a couple of decommissioning items in the decommissioning phase, the on destroy and on application quit that we can listen for as well. So these are all the methods that we can tap into, right, to program our use our scripts kind of thing. All right, and I've kind of given it a little bit more detail. Reset, I mean, quite often we don't use reset to initialize everything. It happens automatically. We could try and call the reset, not recommended for the most part for beginners because it can cause some weird effects. Where we really start is this awake method. Sometimes what we do is we do some stuff in the awake method before or just after the prefab. Remember what prefab is? It's almost like a building block or a class. So I create some kind of spaceship or alien ship. I add all its properties. I describe its materials and textures. I use it as a prefab. I save it as a prefab, and then I can instantiate it with all of its stuff that I just made over and over again, right? I can spawn aliens with the exact same properties, right? But they're going to have different values. So, for example, they're the exact same alien, which is really powerful, right? That's the whole idea of object orientation. Well, this prefab idea, when just after it's instantiated, the awake method fires. So that's a great time to, again, update positions, change colors, update your AI, get line of sight. All that kind of stuff can happen nicely in the awake phase, right? Or the awake method. Start is a very common method. In fact, there's two default methods that come with every script when you start a new script. Start and update. Those are the two main methods. And if you haven't done your tutorial yet, any one of the tutorials, you haven't seen that, but we will do that today. We'll do a little mini tutorial today about moving primitives around the screen and see how that goes. Okay, by the way, what's a primitive? What the hell is a primitive anyway?
Basic shapes.
Basic shapes, okay, what does that mean? Anyone have an idea what a primitive is? A cube, a cone, sphere, plane, right? When I say primitive, that's what those things mean, right? So that's another piece of terminology that I'm going to test you on, right? What's a primitive? And we talk about primitives, moving primitives around inside three-dimensional space in Unity, right? Or creating primitives for testing purposes. A lot of times that's all we do because most often we import meshes, if you will, from other programs, other asset creation programs or different sites, right, online in order for us to be more productive, right? Okay. And we showed you that last day, where to get them from, where to get your assets from. Okay, on application pause, again, this is what happens when the pause is detected. Update order, this is important. Again, we talked about fixed update. Here's an example of some fixed update method, right? I have a vector 3. What's a vector 3? So you're seeing some new stuff maybe you haven't seen before. As I spoke about before, you have ways, I have ways of making you talk. No, I have ways of moving things around, right, in the 3D world. How do I do this, right? Well, one thing to note is I cannot explicitly change the values of components, right, in my game object. We're going to talk about that. I need to create a container, vector, right, in order for me to affect the change location of an object. How do I do that, right? So what is a vector? A vector has direction and distance, right? Math, that's where it comes from. And there's another one, there's a quaternion, which has an angle, right? That I get a kind of an angle or spin. It's angular velocity, if you will. You can actually add angular velocity with a quaternion. With a vector, there's two types of vectors we're primarily going to use. A vector 2, x and y coordinates. A vector 3, x, y, and z coordinates, right? In your 2D world, all you need, for the most part, is a vector 2. Here in this example, we're declaring force, the variable force, as a vector 3 variable, right? It's a data type, vector 3, right? And what we're saying here is transform forward. Forward is actually an enumeration, right? That moves the actual, adds force forward into the scene. We'll talk about that later on. And then also we multiply that by the input get axis vertical. We're going to talk about what that is, that input thing. But what that means is when I'm moving my mouse or my joystick forward or back, I press the up or down buttons, arrows, or the W or S keys, then I get input numbers from the input get axis method. Well, so I'm going to show you that later on. And then it says access the rigid body component here, and then add force to it, the force that we just calculated in, which is a vector 3. Okay, so I'm adding force, this vector 3, to the rigid body. Whatever it was before, I'm adding another force to it. Okay, and add force would be the method that we're applying to the rigid body. Okay, so that's really fixed update. And if you notice what it says here, fixed update is primarily used for physics. So again, this is my mnemonic, if I can't remember what it means. Fixed update, physics. Physics, fixed update, right? Seriously. If you don't remember what it is, that's what it's related to, right? Update, everything else, right? Pretty much. Late update, some stuff that we kind of try and do that we can't do in update because it's a timing issue, right? And you'll see that later on. All right. So here's your update. And this is an example of update. Well, one thing I have to note, sorry, before I move on from slide 13, is that it says here that in fixed update, because we're doing a physics update, we don't need to multiply our values by time delta time. What the hell does that mean, time delta time? Time delta time is actually the time constant. It keeps track of the time every millisecond, right? And it keeps track of the difference in ticks in time. So for example, it's almost like, what's the difference between the last time I checked time delta time and now? It gives you the difference. So the difference in milliseconds. So you multiply that sometimes by movement in order for you to get smooth movement, especially when you add force across the scene. Here, because we're using our physics update, fixed update, right? We don't need to do that. We don't need to use time delta time. We can avoid doing that. And some examples will show you that online. But in this case, because we're using a regular update, again, it's called once per frame. Frame rate can be variable depending on the device, right? We have to use time delta time to smooth out our movement. Otherwise, what ends up happening is we get sometimes an irregular motion, right? So we multiply by time delta time to get some smoother motion according to the time. So we use the frame rate plus time, right, to get smooth motion or changing locations, that kind of stuff. And we'll see that a little later. Okay. Now, again, we don't always have to use this depending on how we do our code, and I'll show you a way of not using it next time. But we can see that we're defining a variable called distance, which is of type float. And then in here, what we're doing is we're deciding the speed. The distance is the speed times the direction, right, times time delta time. Well, the direction here is horizontal. And again, horizontal, these things in quotations, is an enumeration that tells us we're listening for right or left movement. And we'll go over this. I know this looks weird. You're like, so what are there? There's horizontal. What other enumerations are there? I mean, you need to know these. You need to memorize some of this stuff. Once you've seen it a bunch of time, you know, it's okay. This does not come up, unfortunately, in code hinting. So if you were going to actually use IntelliSense in your mono-develop, no. It'll give you the input.get axis, but the horizontal, vertical, and all the other stuff that comes up, you need to remember that or look it up, one of the two, right? Okay, so we'll talk about that and what's the advantage, disadvantage of using that kind of stuff. Alongside with the event life cycle of Unity, all right, there's also physics events, okay? So when I say physics events, I'm really talking about collisions, right? That's what I want to talk about. And there's two that are really more popular, if you will, or more used than the others that I've seen, which is on collision enter and on trigger enter. Those are the two big ones. There's other ones, you can do different things. And let's think about that. If I collide with another object, right, my collider, depending on the shape of my collider, if it's a cube, my collider is a cube, and I have the other object has a cube type collider. If they intersect, right, the two cubes intersect, I have a collision, and I can listen for an on collision enter when my collider enters another collider's or intersects with another collider. Then I have an event that sparks that I can listen for. All right, that's on collision enter. On trigger enter is different than a collider because I may not want to make it so that it bounces off another object. And by the way, when you declare a collider, like a game object to have a collider, you add a collider to a game object as a component, it automatically works because of bullet physics, right? You don't have to really do a lot of stuff. If you want certain things to happen when they collide, not just bouncing around, but exploding or something, then you have to write some script, okay? So again, there's two different things you can do here. You can actually affect movement, direction, you can make it bounce, reflect, all kinds of stuff, change color, whatever you want. It's up to you, and it's all up to you how you trigger it. And let's look at a couple of these examples. So one is the on collision enter. And when is this called? It's called when the collider or rigid body, so remember we talked about, I showed you rigid body when we first, on day one, we did kind of that Blender tutorial where I had my sphere, remember? And when it fell down, it was just a regular cube collider. But when I changed it from a dynamic body to a rigid body, it started to roll. It actually gained the ability to have angular velocity and speed, so it could change directions, right? From an angular perspective, right? And that's the thing that a rigid body allows you to do. Blender also has soft body physics as well. And we can talk about soft body physics another time. But right, what I'm saying is it gives you the ability to detect your collider entering another collider space or intersecting with it. And there's some really good examples here online. Here's an example of code to detect that. So you have, and again, you're going to see this a lot. When I say using Unity Engine, the using statement is like an import statement. This is going back to C#, right? And I'm actually, I'm saying, hey, that Unity Engine namespace, I want to use it as part of my code so I can access classes that are part of that namespace, right? And if you notice, there are two methods that are part of our event lifecycle. One is the start method, where I'm saying my audio component now, because I've defined audio as an audio source, is equal to get component audio source. And if you notice, whenever you see the get component class being used, right? And by the way, that's one of the most popular ones I'm going to show you today, get component. You always have these little angle brackets. And in the middle of the angle brackets, we have the type of component that you're going to be affecting, okay? So I'm saying, hey, make a reference to my audio source, and I connect it or bind it to my audio variable. That's what I'm doing here. I'm binding it together. And then in here, when I'm colliding, on collision enter, right? I'm creating a collision variable, a local collision variable here, right? Right here, that's what this is doing. Here's my local collision variable. And for each collision that's happening, I want to make a noise, is really what I want to try and do. If my collision, my relative velocity magnitude is greater than 2, I'm going to play my audio, which means, you know, if my velocity is really faster than 2, then I'm listening for an audio. I'm going to create an audio event. But again, the on collision enter is that method that we're overriding that's built in to the physics cycle, if you will. Okay. Same with on trigger enter. Here's on trigger enter. Again, it's called when the trigger, the collider, enters another trigger. What's the difference between a trigger and a collider? Well, remember, sometimes I don't want physics, bullet physics, to take effect, but I also want to detect a collision or something that's passing into a space. And a good example of that would be a boundary. I want to create an invisible boundary for my objects, right? And I'm moving from my object, my main player or my avatar, whatever, around the screen. As soon as I leave the screen, if I enter the boundary, the invisible boundary that I've created, there is a on trigger enter event. I can create a trigger, not necessarily a collider, because I don't want it to bounce or anything like that. I don't want physics to take hold, right? But I want to detect something. Another way to do that is if I enter a door, I'm walking, I'm doing a first-person shooter. I've got my gun, right, hosted right here. Usually the first-person shooter, by the way, the gun is in the person's eye, right? Yeah. Okay, but so I'm like this. I'm bobbing in and out. That's my animation, right? And as I'm going towards the door, I collide with the door, or I press a button to open the door, and then as I pass through, there is a trigger happening, right? I can detect. Also, if I get to a stopping point, if you will, right? You know, if I get to a point in the game where it saves automatically, sometimes you can set up these points, a waypoint, if you will, right? I get to a waypoint, it triggers an event on trigger enter, right? That's when I can use that. It's not a physics collision, it's a trigger that I can trigger for all kinds of stuff. For example, if you enter a room and you want a crane that swings around to knock you off your feet or something like that, you entered the room, it's a trap, right? You can use it as a collider. You collide, you know, you stepped on a plate in the floor, right? Just like Dungeons and Dragons. You step on a plate, there's a trap, right? Or once you enter the room, there's an invisible trigger that's surrounding the door. So once you pass into the room, boom, the trap triggers, right? It's not a physics event or collision, it's a trigger. Okay, and there's an example code here of how to do that. So again, on trigger enter, I'm going to, when I collide with something else, my other collider, I'm going to erase my game object. Whatever other collider I'm colliding with, whatever the collider that belongs to, or the other trigger, erase that game object. So if I bump into something else, in this particular case, that something else gets destroyed, right? Okay, so that's really that. Late update, again, called once per frame. Calculations that couldn't have been performed in update, they're completed. You want to take those calculations. Sometimes you want to generate a score, or you want to update a mini map or something like that. Late update is someplace you want to do that. Okay. I'm not going to talk too much about rendering. One thing to note is the camera does something called culling, right? When I say culling, it actually renders the scene, right? It actually determines what part of the scene to show and what part of the scene to you know, exclude from your visibility. Remember, the camera gives you a limited view, right, of the game world, right? And it culls all the other, you know, images or objects. It only shows you the stuff that's inside of your perspective. And depending on the type of game you're playing, 2D or 3D, different kind of cameras come into play. I'm not going to go into the rendering phase here too much. I'm not, but it's here for your viewing. On GUI is the one that we look at a lot. Sometimes when we want to repaint things like text events, want to repaint things like button hovers and all that kind of stuff, that happens on the on GUI rendering event. Coroutines is a little bit of a complexity for beginners. When they look at it, they're like, hey, what's a coroutine? Hey, what is threading anyway? You know, multi-threading, right? You're creating a multi-threaded application when you use coroutines, which means you have, like I said before, think about it as 2 car lanes, right? Your main application runs on 1 car lane, and then all of a sudden you create a thread, a coroutine, whoop, now you have another car lane that you virtually create for that time frame. And then when you're done with it, whoop, it's gone. You don't need it anymore, right? So you run another process over here in the processor alongside with the main process. That's the coroutine, right? And sometimes we need to do that. On destroys, when an object is destroyed, you can listen for that. We talked about that too much. When quitting. And now let's move into Unity's game object class. This is good. This is kind of our main thing. Without the game object in Unity, you can't do anything. In fact, every game object in Unity, anything in Unity is a game object. Lighting is a game object. You have any kind of props, you know, whatever you create, they're all game objects in Unity, all right? So let's try this out. Let's fire up Unity. This is a great time to do this with me, right? And let's take a look at this and inspect it a little bit more carefully, right? So I can talk to death, and you guys will be bored out of your skull unless I get you going, right? So I'm going to start off a new Unity project here. And again, I did it yesterday. I've got this COMP305 lesson 2, but I'm going to make a new one that I'm going to call COMP305-lesson 2 without the 02, right? I'm going to store it somewhere online where it says, you know, mine is my desktop. I have a choice of creating something either 3D or 2D, right? And for us, because we're making our assignment number 1 is a 2D game, right? And again, I'm giving you a 2D game first because it's easier to understand X and Y as opposed to understanding X, Y, and Z. That's another form of complexity to get into. We're going to get into that as well, but I want to make sure we start with 2D. So again, we can click 2D, and that kind of sets certain things up for us, our camera and so on. If you're using Unity 4, by the way, it's very similar here. You can add the 2D package, which is part of the assets, right? If you're using Unity 5, all you have to do is what I'm doing right here. In my asset package, there's a lot of different things here that I can include, right? As a starter, I can include starter assets right here. And anything I download and install into my Unity from the asset store will be seen here, right? So if I download, example, some other kind of assets or whatever, I can always include them in every one of my projects. For now, let's just leave it as is, so we're not going to include any additional packages, right? I'm going to create project. Okay, it's going to take a moment for my Unity to create it. And if you notice, I've got this, this view right here. And this is my default view that I typically work with. I've learned that this is kind of what works for me. You may also choose, again, your layout might be the default layout. You might choose to use this layout here. That's fine. I find this is okay too. I just like, because it maximizes the size of this, right? But a lot of times I find I'm comfortable working, because I'm a coder, I'm comfortable working in this view and just seeing a small view of what's going on here, unless I want to do a big preview of the game that I'm playing, okay? All right, so what do I do here? I've got right now my main camera, like we talked about before, right? And that's all that's in my scene. So if I actually click onto it and press the F key, I can zoom in or focus on the camera. And if you notice, there's a square here, right? It looks like a square that I'm seeing right now. Well, this is only because we're in 2D. If you notice in the top here, there's a button that can transform the view from 2D to 3D. There's 3D again, right? So let me just move this around, right? So I'm going to kind of drag this around. I can use the hand control here at the top, or the Q button. Q. By the way, the 4 keys that you need to remember. Look at the controls up here. Q, W, E, R, right? And those are the top part of your QWERTY keyboard here, right? T does this part, right? Which is the fourth one. So Q, W, E, R, T. It equates to all the shortcut keys that control your keyboard up here, that control these items. If I want to do a move, I click Q, and now I have my hand control that I can move things around in 3D, right? That's what I can do here. Now I'm looking at it in perspective view. Remember, when we do 2D, we look at it in orthographic view. That's the other viewpoint. It's flat, almost like we turned a 3D view into flat. So if I click on my camera now and press F, I can focus where my camera is. I can also zoom in here if I really want to see my camera. Oops. And there it is. Now my camera also shows a preview of what it's looking at. Right now it's not looking at anything. So let me just back out here a little bit. But if you notice, it's in a big box. Why? Because if I rotate the box, I'm just going to rotate this thing around so I can look at the Z. Look what's happening, right? Here's my camera, and this is my point of view. I'm looking at this down the line, right? This is my view. It's kind of like almost like an elongated view, okay? Let's go back to 2D for a second and see what happens. It's gone, right? It goes back to orthographic mode. So I don't see any perspective whatsoever when I click this 2D button. Very important, okay, to note, right? All right, I want to add a game object, but before I do that, the first thing when you set up your scene, right, in my opinion, this is just me, I would set up my folder structure for your game. Any game you make, set up your folder structure. How do I do this? If I'm set up like this, right, if this is my default view, you notice here I have an assets folder, and on the right, the assets folder shows empty, right? I can right-click here and create a folder through my context menu, right? And I'm going to create my first folder is going to be called scenes, right? The capital S and an underscore. And again, I like that default. I'm just going to move that around a little bit. I like that convention because what it does is it puts scenes at the top of my folder list. Now this is pretty big as a folder. I don't care to see it that way. What I want to see it is in a list view. So if you notice down here there's a slider at the bottom of my assets. I'm going to slide that right to the left, and it becomes a list. Okay. So again, I can now when I click on this on the left-hand side here, so I'll expand this a little bit so you can see it. Right here, this assets folder here underneath that we have a scenes folder. If I click on the scenes folder, now I can add scenes in here, and I can see all the scenes that are in my folder by clicking here on the left. Okay, so just again, it's just semantics, the way I like to do things. You can certainly map things out your way, right? Let's go back to assets. Let's add the rest to prepare ourselves. So I know, take a look at the favorites. This is a great example of what I want to add here. Materials, models, prefab, scripts. Let's add those in. So I'm going to create materials. I'm going to create models. I'm going to create prefabs. Prefabs is a special folder. Be careful. You should name it exactly that, prefabs. And I'm going to name scripts. Okay? Let's add a couple more. Let's add textures. That's also possible, right? You can have textures that are different than your material, right? And maybe material should be called materials, not material, Tom. Typing error. Materials, models, prefab, scripts, and textures. And what about anything else, like sounds? You can have that in there too. We can't forget those. So let's add that in there. Sounds, you know, maybe multimedia. You can call them whatever you like, but you want to organize yourself at the beginning. Okay, that's cool. The next thing I want to do is I want to create a new scene or save a scene. So I'm going to say File on the Unity menu, File, Save Scene. Now, I've never saved a scene, and it's going to ask me where to put it. Let's not put it anywhere for a second. You can certainly specify the location as the _ scenes folder, but let's not put it anywhere, and let's move it around after. All right, so I'm going to call this main. And when I click Save, it's going to save my scene inside the main hierarchy in the root of my assets folder. Okay, this isn't where it should be. This isn't where it should be. My main scene, my main, should actually be placed inside of my scenes. And I'm just going to drag and drop and move it in there. Now when I click on the left, if I click my scenes folder, I can see main is in there. And I can have more than one scene. Again, a scene is a different screen. It could be the initial screen that you see to start the game. It could be the actual game world itself. Level 1, level 2, level 3, like I said before. Could be the game over screen, right? These are scenes or transitions. Those are all scenes. And they're each of them have their own game world, complete, right, that are separate from every other scene, okay? Okay, cool, so this is my main scene. I've saved it, right, as this main. Now I can start building stuff out. And what I want to do here is I want to put together a primitive. Let's do that. And now there's a couple places to do this. I could do this here in the hierarchy. I could use the Create menu. Take a look. Create, 3D object, blah, 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 whatever, right? Let's not create a 2D object yet, even though we're in 2D mode, because I need to create a sprite. I don't have any sprites right now that I want to share with you. Next week, I'm going to have a collection of sprites and a whole project that I'm going to share with you from an assets perspective that we can move on, something that I've been creating over the last little while. And some of you will recognize it if you did web game programming, right? I'll use the exact same the assets, but we'll do it in Unity, right? So that we can do both this mail pilot stuff that we did. It's going to be mail pilot, but Unity, right? And how do we do mail pilot? So now you can see it in both ways. And if you take that to the game session with me, it's a great thing to compare it to, because now you're doing the exact same code, but in 2 different kind of game engines, right? Which is really cool to learn. All right, but for now, let's use a 3D object. Now you can do it here and click Cube, or you can right-click here and it provides a context menu. That's also, and that's what I like. I kind of prefer that, and press Cube, right? Now I'm going to make a cube, right? So you can make a sphere or whatever else you want, but I'm going to make a cube. All right, it appears in the hierarchy underneath the camera, right? But it also appears black. Hey, wait a minute. Here's something else. If you notice, when I create a cube, where does it go? My transform property, we're going to talk about this in a second when I flip back to the PowerPoint, right? My transform property shows the Z location at -10. Whoa, okay, I don't want it there. For me to reset my transform, in order for me to see my cube, because look down here, and there's 2 windows here. The scene window, which is where all my assets are, and down here, there's the game window. I don't see nothing in the game window, and if I don't see anything in the game window, I'm not going to see anything when I play the game, all right? Remember that any game object you bring into being, you're like the god of the world, okay? Think of it this way. You're breathing life into these assets, right? They appear. They're actually physically in the world. They just may not be in your view, right? So we need to bring them into view by changing this either value to 0. You can put it in the middle of your game world, or you can press the gear here. Here's the gear. And then you can just click reset, and that'll reset all your values to 0. Now we can see it down here. But hold on, it's black. How come it's black? Anyone have an idea why it's black? It's black. Huh? What do we say over here? Well, materials, yeah, okay. What else? No lights, right? This thing is black because nothing. Remember, no lights, no color, guys. Color comes from light, right? Everything is black in darkness. If you think about it, right? There's no light, nothing to reflect. I'm sorry to say that, but that's how it is, right? So, huh?
The shower thought.
There you go. Sorry about that. I didn't want to make it a shower thought there, but you know, like you're saying. But yeah, everything is black, right? Everything's dark. You can't see anything because there's no light to reflect off of. There's nothing to. There's no light being cast on the object. Okay, so this is one. I want to rename this object to player. So how do I do that? I have to click once and then click again. Okay, it's not a double click. And then I name this object player with a capital P. Okay, we're going to get back to this in a second. I wanted to bring this up so that we have a context to talk about when we talk to the PowerPoint presentation. Okay. Okay, one thing is my player object is down here in my scene, but I want to focus in on my player object. I can press the F key when I'm in the scene to focus in on it. So here's my player object, right? If you notice, it's a big square right now. But it's really not a square, is it? It's a cube, right? I'm seeing it as a square because I'm looking at it from a 2D lens, right? So if I click on this 2D button up here, boom, it becomes a cube again. And if I press the my Option key or my Alt key on the Windows machine, and I kind of pan around here, I can see that I can look at it from different perspectives, right? But really, when I go back to 2D mode, bam, it's just a square. That's what it looks like to me in 2D mode, right? Okay. Some review. Okay. Let's get back to this PowerPoint for a second. This is important for us to understand this thing. So back to the PowerPoint. So what does it say? It says game objects are fundamental objects. In Unity, we just created a fundamental object, a primitive, right? They don't accomplish much by themselves, but they're all containers for components. If I create a game object, an empty object, and we saw that in our an example script that we made last time for our tutorial, a game tutorial, right? We have empty objects that can be used to group other objects together. Like, for example, all the hazards can be grouped in there. And you can have multiple asteroids as hazards, multiple enemies under the enemies game objects as an example, right? But all of them, every single one of them, has one component you can never get rid of. It's the transform component. That comes part and parcel with any game object. Any single game object you have has that. Let's go back and check Unity to confirm that. Here's my main camera. Hey, there's my transform, right? My main camera shows me that right now it's not at 0, 0, by the way. It's at 0, 0, minus 10. That means it's into the scene. It doesn't matter. The Z coordinate here has no bearing on my scene whatsoever, right? Because remember, I'm looking at it from a 2D lens, so I don't care, right? Except when it comes to layering. So that's one thing, one thing to note. Okay, so that's where my scene. My main camera has a component. My player, it has the transform. And anytime I add a new component in there, I'm going to add an empty component and get rid of it for a second. How do I add an empty component? Right-click, create empty. Right? When I create my empty component, here it is. Oops. Hey, look what's happened here. What is this? Fahim, what's this? What's going on here? Hierarchy. So this game object is a child of the player object, right? So in order for me to make it a part of the root hierarchy, I got to pull it out, right? And I can reorder this the way I like by dragging this object anywhere I like. It doesn't make a difference in the game world, but if I want it to be down here or up there, it's up to me how I want to organize it, okay? But if you notice my game object, this is the default name of the game object, and look over here what I got. It's empty. I don't have any colliders or anything, but I have this transform component, and I can't get rid of it. If I go here to my gearbox, I can't delete. It's not available, right? It's required. Okay, so that's one thing to note for all game objects. Some of you may already know this because you've done the tutorial, but I'm going over it in fine detail for those people who don't know it, okay? All right, so that's one. And the other thing is that if I go to my game object here, again, the transform component is always there. We just kind of covered that. There's these variables that are part of every game object, okay? So active in hierarchy, a Boolean variable, active self, and so on. The ones that we use a lot are the layer variable, okay? Layer variable. I can put any object in any layer that I want, from layer 0 to 31, okay? That's 32 layers that I have, right? So these objects, if I put them in the same layer, example of this would be all my doors in my game are put on the same layer, in the door layer. Why would I want that? Because I can affect every door the same, because they're all part of the same layer, even though they're not part of the same group. They could be a doors in any part of my game, right? Also, I can turn objects invisible or visible or whatever by layer, right? I can affect them by layer. It's another way of grouping objects together or doing things with the objects, right? Okay. And the other part is the visibility piece. If layers, there's different layers, but there's also ways of showing or hiding objects, right? By putting them behind other objects in the same layer. And we'll talk about that later on, right? Especially when we work with 2D. Layer order is very important for us to see how things stack upon each other, right? As a display object. Okay, then we have the tag. And you're like, tag? What's tag? Well, a tag allows us to access another object from one object from another object. And you're like, so what do you mean by that, Tom? Well, remember that each object can have its own script, right? So I have my own script file. Each object has its own script. So imagine I have my script, and the script is part of its own namespace that's part of the object, but somehow I want to access another object. How do I find that other object in the C# namespace? I can't, right? Unless I create a unique name or tag for that object, and then I can find it by tag name. We don't do it physically here we don't actually assign the tag typically in my script. I really do it in my inspector. Let me go back to Unity for a second to show you this. So here's my player object, and on the right you can see that there's a tag property on the top of the inspector. Right now it shows untagged, right? I can change this, right? And there's some default enumerations here. One of them is called player. I might as well make my player the player tag. Now I can find my player by, find by tag, right, kind of thing. There's a certain function you can use to find my player and include it or make a reference to it in your script, okay? So I can create a binding, if you will, right? Locally, I can have my script. Let's say my game controller script that has nothing to do with any other object, but I want to make a binding to my player tag so I can affect my player somehow, position, color, whatever, right? And I can do that by using this tag, right? Here's my layer, like I talked about before, and there's some default layers here. There's transparent effects, all those layers. Any object that I want to ignore a raycast, the water layer, a UI layer, and I can make my own. And same thing with my tags. I can make my own tags, my own custom tags here as well, right? All right. So very, very cool. This is really important, all right, for us. Okay, so let's go back to the PowerPoint presentation here. So again, I've got these different properties that are part of every game object, as well as this transform property as well, which is actually a class, right? A transform object that's part of our game object. Okay, and again, I'm going to talk about transform in more detail later. Okay, so here's the general form of, if I wanted to create a game object from scratch, this is how I would do it in script. Public game object, and then the name of the game object. I'd have to name it. Why? Is this the tag? No. This is the name that appears in the hierarchy. An example, this is the player name. So if I go back to Unity, player, this player object, the way it's named here, is the name property that I'm asking for in here, right? So this is my name. So whatever I name it, that's how it appears in the hierarchy, right? Now here I'm creating an object dynamically, right, in script. I'm saying my player is a game object. What am I doing here? Have I instantiated an object here yet? What's the answer, Fahim? Have I instantiated an object player yet?
No.
Here, on this line?
No.
No. What have I done?
Just declared it.
I'm declaring it, but when I declare it, what I'm actually doing is saying to C#, hey, C#, put aside some memory because I need this shape. This class that I'm going to create an object from has a certain shape and memory requirements. I want you to set aside some space for me. Hey, I don't need it yet, but just reserve it for me. Like almost like reserving a seat for the movie, right? I haven't gone to the movie yet, but I'm reserving a spot, right? Save my seat, save my chair. I'm gonna be right next to you. Right? That's what it's really doing here, right? I'm creating a reference, right? That's all I'm doing. Now here, my player itself, I'm with the new keyword. That new keyword breathes life into my player object by passing through into it the requirement. And the requirement for this signature, my game object's constructor signature, is a string name, right? Which is player. In this particular case, it's just result. Now you can make it anything you want, right? In this particular case, we're using player because it's the player example, but it could be any object you're creating with any name you want to make. It's not an enumeration, all right? Okay, here's one, player.addComponent rigid body. Oh, I want to add a rigid body component to my player object dynamically. Here's another one, player.addComponent box colliders. Now I'm using a collider, I'm adding a collider to my object. So I can build or stack, it's an incremental thing, my player object with different components, whatever components I want. Let's show you this in Unity, right? So here's my game object. Right now it has my transform. Look, here's my add component right there. This is what I'm doing in code. I'm clicking the add component button, and I'm adding something. An example of that would be if I want to add in a collider of some sort. So I'm going to go to physics. If I want to make it 2D physics, I can go physics, rigid body 2D, right? That's the kind of collider, or box collider 2D. I could do that. Let's add that in. And if you notice, it gives you some values by default, this box collider 2D, right? So that's another component I've just added to my game object. I'm going to erase the game object. I'm just using it as a example here, right? But if you go back to the script here, here's another one. So rigid body, I've added a rigid body, and I want a box collider, right? So let's go back. So, I mean, this is my box collider. And again, but I can add in a component, a physics 2D component, right? A rigid body 2D. I need both. Why do I need both when I do physics? A collider and the rigid body properties. Anybody have an idea? You don't need to know this, by the way, right now. This is new for some of you, for most of you. I don't have a rigid body definition. I don't have properties like mass, linear drag, angular drag. I don't have, physics doesn't know what to do with this shape, right? Until I establish a rigid body, right? It's invisible. The object doesn't get affected by physics at all, right? That's bad. So I need both. I need the box collider, which is the shape of my collider, right? And by the way, I can edit my collider. Right now, if you look at my game object, and if I press the F key to get into it, you don't see it because it doesn't have a shape. I don't have a mesh renderer for this empty game object I made. There's no shape to it. Physical shape, I'm talking, a primitive shape. It's just an empty object right now with a box collider and a rigid 2D body, right? Let's add a mesh collider. So how do I do that, right? Well, I'll go to mesh, and then I can use a mesh filter. I need that, right? And there's no mesh right now. And let's add another one. Let's add a mesh renderer, right? Kind of weird. Here's mesh renderer for casting shadows. That's what the mesh renderer does. And my mesh filter, well, there isn't any. So if I click this little button on the right, I can choose a cube, a capsule, a cylinder, a plane. These are my default primitive objects. Let's make it a cube again, right? See, here's my cube, and we're gone. And now when I focus in on my game object and press F, right now I see my sphere, my cube again. And if I get out of 2D, it's layered on top of the other game object, right? My other player object. But this is the actual object. I've created a new cube from scratch by adding components to my empty game object. That's all it is. A game object is a container, and you can layer things on top of inside my container to define its shape and its properties. Okay, it's the basic element of everything we do in Unity, the game object. Okay, let's get rid of it for a second. I'm just going to delete it out of my scene. Okay, going back to the player here. And player has all this stuff already, if you notice. Mesh renderer. The only thing that we didn't add in was the default material, right? We didn't have a material that was defaulted. That's one thing that was added in automatically. Okay, let's go back. So I'm going to go back to my PowerPoint for a second. So that's what we're doing here. When we say add component, then we're clicking this add component button, but we're doing it in script. Here's the script of that, right? Add component. And you can do that dynamically as well as in your UI, right? There's a bunch of different methods that are included in our functions, if you will, that are included in our game object, right? So things like add component, compare tag, get component, which is probably the most common one we're going to use today, right? Get component to make a reference to a component object, right? And there's others in here as well, right? There's also some static functions that you'll see, like, for example, find with tag. We just mentioned tag. I want to find an object with tag and create a reference to it, right? Inside my script, I want to point to another game object that's not part of my game object. Remember, each script refers to a game object that it's attached to. If it's not attached to a game object, the script has no effect on your game. Okay? Every script has to be attached to a game object, even if it's an empty game object. Has to be attached to something in order for it to kick off, in order for it to be instantiated in the game, right? The script has to be attached. So if I want to connect one script to another, and the other script kind of connects to another game object, I can use this find with tag function. All right. We're almost done. Then we'll skip out of this and take a short break, right? Here's my get object, get component method. This is very, very important. Again, we use this in order for us to make a reference to a component inside of our game object. Example, I want to affect my location, right? I want to use the get component method with whatever the type of component is in the middle to make a reference to it. Okay, so let's take a look at this. So that means I want to make a reference to my transform. The transform component would be inside these angle brackets here, right? So I say get component, whatever the game object is, dot get component, right? And transform with these parentheses, dot, and then I can access the transforms properties, dot position, right? Warning, you cannot affect a component's properties directly in Unity, right? Which means I can't say get component transform dot position dot x is equal to 0. Can't do that. You can do this. Get component transform dot position is equal to vector, whatever my vector3 object is. That I can do, right? So be warned, if you try and do this directly, you'll get an error in your code saying, can't do that, can't affect a component directly. That's one of the most common errors beginners get, okay? Let's go back to 2D here because that's confusing. All right, let's go back. So that's one thing to note. So if you notice here, I'm making a reference. I have, in this particular example, a hinge. By the way, these examples all come from the ones online. Here's a hinge as an example. I'm making it a hinge joint. That's what I'm using, a common class, hinge joint. And here I'm saying my hinge then is GameObject.getComponent hinge joint. I'm making a reference to the hinge joint that belongs to the game object that this script is attached to, right? And then I can use my hinge just like any other hinge. Hinge.useSpring is equal to false. I can change properties of that directly. Okay, one more thing and we're done. 2 more slides. And then I see some of you glazing. Bear with me, okay? Bear with me. Here we are. The input. If you don't have the input class, nothing goes on in Unity. You can't make it go. If you want to affect your player and you want to do something, you need to use the input class or the input system, if you will. There are some enumerations we have to remember. And again, we're going to use the input.getAccess for us to use those enumerations. One of them is horizontal. And what they do is they affect the A and D keys. So if I say input.getAccess and in brackets horizontal, I'm actually getting an integer number back that's telling me either I'm moving left or right. A or D keys or the arrow keys. The arrow keys, if I press the left arrow or right arrow. Okay, that's what it's getting. So I'm getting input back from the keyboard, all right? Or the joystick. The joystick can also go horizontal, right or left, right? Same thing with up or down. That's vertical. So if I use the vertical keyword, the vertical enumeration, I can listen for things up and down, right? Same with mouse X and mouse Y. Mouse X and mouse Y, I can know the exact coordinate of my mouse, the X or Y coordinates on my screen. And that's really important sometimes, especially when you want to mouse over something to show an effect and it's not a button. It's not a GUI element, like you're mousing over the wall, because you're searching for something on the wall, like you're searching for a component in 3D space. Hey, look, I found a secret component, a secret part in a wall, secret compartment or whatever. I want to open it up. My hand, my cursor, as it moves over the wall, it detects where my cursor is and then changes it to a hand or some kind of other kind of key code, some feedback to the user to say, hey, you can look inside the wall here. You detected it because you have a special capability to do that, right? Fire 1, Fire 2, Fire 3. Again, it maps to your either your joystick or your mouse, and also the Control, Alt, and Command keys. Okay, so these things here, these horizontal and vertical mouse X and mouse Y. These are, like I said, enumerations. They're not going to come up in code hinting. You have to remember them, right? Or access them. Yeah.
Is there a space between mouse X and mouse Y?
I believe so. I believe so. Yeah. Okay. We can look it up, but I took this right from the example online. Okay. And the same thing goes with, here's a good example of that. So here's, I'm in my update method, right? I'm saying if input.getButtonDown, that's another type of input, all right? If I'm listening for a button down, not just a get access, if my input button down is fire 1 is true, right? Then I can give my input mouse position. I can use debug.log, and debug.log is one of the most common things we use right, as an example, to detect or to send information back into the console. Hey, speaking of the console, before we end for this particular video, let's go back to Unity and add a script to the player, right? Here's something I like to do. I can minimize or collapse some of these components that I'm not going to touch. I'm going to leave the transform component up, but I want to add a script here to the player. There's two ways to do this. I can go into my scripts folder and right-click and then create a script. I could do that, right? Or if I want to do it the easier way, which I recommend, just add component scripts, right? And you can add in a Unity script right here. So here's my player, right? Add component. If I script all the way down to new script, that's what I wanted. New script, and then I can rename this script player controller or something like that. It's all your choice. Here's my player controller. And I can choose my language, C# or JavaScript. Someone in the earlier class said, hey, Tom, can I use JavaScript? Because I'm much better with JavaScript than C#. Guys, don't be ridiculous. Yes, you could, right? But what I'm saying that is, why? C# is way more powerful in this particular context. Yes, you might know JavaScript, and from a compatibility perspective, if you're going to make a web game, might be a good idea. But in this particular case, C# is the more powerful language. It's got a lot more structure to it, and it's you're better off using C# in most cases. All right, so let's do that. Create an add, and when I do that, it's there. It's part of our player controller. But oh no, what happened? Let me go back to assets. Look, my player controller script is hovering over here. I don't want it here. I want it inside scripts. So I'm going to pull this thing into my scripts folder. So I want to organize it. Now when I click on scripts, it's now in my player controller. And my player controls in my scripts folder. And I want to organize all my scripts in my scripts folder, because if I say all scripts, if I click my, my favorite over here, it'll pop up as well. All right, so here's my player controller script. How do I get to it? I have to double click on it. Let's double click. Are you asking a question? Or are you good? You have to double click. Hold on. And when you double click, I'll come back to you in a second. If I double click, if you notice that I have my script, and remember what I told you, here's two default methods that are included in every script, start and update. On start, remember what start happens, when we add something in the start method, it fires or triggers on initialization. As soon as my object enters the scene, it triggers, right? So this is a great place to add a debug. Let's add a little comment here, or a debug value, debug. And here's MonoDevelop. This is what you're seeing here. MonoDevelop is coming up. You could also see Visual Studio. If you've got Visual Studio on your system, it works just as well with a nice little plugin, maybe even better, right, than MonoDevelop, right? So debug and then .log is what I want to put in there, and kind of say, you know, something like player entered the scene, right? So that's something that's going to happen. So my player entered the scene is going to come out. Okay, go back to Unity now. Hold on, where's my console? I don't see my console window here in my layout. I can add it in. I'm going to go to Window, right, all the way to the bottom. There's Console, and you can press Shift, Command, and C as a quick shortcut for Mac users, or Shift Alt C, I believe, for Windows users. And then here's my console, but it's hovering right in the middle of my screen. I don't want it there. I want to reposition this thing by clicking on the tab and moving it right next to my scene, right? So now I have my console next to my scene. I can click between the two. This is just a new way of viewing things for me, right? Okay, cool. So I want to start my game. How do I start my game? My simulation is going to start with my play button, right? So if I click the play button here, if everything goes well, then on my console, I'm going to hear player entered the scene, which is exactly what I typed here in my script. Anyone not get this? And if you haven't, let me talk to you during the break. Okay, I'll come over to you during the break. All right. So again, debug.log is a great way of showing things on the screen. Think about it from a C# perspective as console.writeLine, right? See, you would have tried using console.writeLine here, it wouldn't have worked, right? Why? Because this isn't regular C#, guys. It is bastardized C#. It's Unity C#. It's a subset of C# that we're using just for Unity. And the reason why, and if you'll go into this, is once you realize that, don't get hung up on all the C# stuff. You know C# syntax, but this is something new you're going to learn, how to use Unity. The stuff you'll learn here is transferable. You can use it in Unreal and other game engines because it's very similar. Even when you program Android, it's going to be very similar because even Android has its own life cycle that you need to learn. okay? So I want to pause it here. I'm going to save my script, and I'm going to pause it here. And we're going to take a short break, 10 minutes, and come back after everyone's had a chance to go to the washroom, have a smoke, talk to their girlfriend, blah, 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 right? All right.